Welcome. We are in Algebra 1, first unit, Algebra Foundations, the fourth skill, combining like terms with negative coefficients. Let's go. So this one says we need to combine like terms. Like terms will have the same variable, or there won't be a variable, they'll just be constants. You can add constants to constants, but you can't add a constant like 3 to this monomial 5 times j, because we don't know what j is. It could be anything, and so that would change the outcome of adding 3 to 5 times whatever. So in this one, we need to combine j's. We've got negative 5j's and negative 2j's, so that's a total of negative 7j's. And then we have plus 3. So I combined the j's, I counted them essentially. I have negative 5, so I went to the left on the number line, right? So if this number line was j's, and I had 0 here, I'd go 1, 2, 3, 4, 5. I'd be at negative 5j. And then I'd take negative 1, 2. And that put me at negative 7j, okay? So that's a way to visualize it, if you like. But this 3, it's not a number of j's, so I can't graph that 3 on this number line of j's. So here we go. That is our solution, negative 7 times j plus 3. And our next question is negative 4p plus negative 6p. So we're adding a negative to a negative, so we're getting further away from 0. Negative 4 plus negative 6 is negative 10. And it's a number of p's, so negative 10 times p. This is 8n plus 12 plus negative 9 minus negative 6n. Okay, so I can combine constants, so we'll do that first. We'll write out the expression, except we will combine 12 and negative 9. 12 plus a negative 9 is like 12 minus 9, so that's 3, positive 3. So 8n plus 3 minus negative 6n. Subtracting a negative is addition, so I can rewrite this as 8n plus 3 plus 6n. Now I can't combine the 3 with the n's, but I can combine 8 n's with 6 n's. I'd have 8 plus 6 of them. That's 14. So 14n plus 3, and that's as simple as it gets. So we'll enter that answer, 14n plus 3. And we'll go to the next problem. We have negative 3k. I notice we have no other k's here, so I can just enter the negative 3k to start with. And then our constants, we have subtracting a negative, which is addition, so plus 8 plus 2. Plus 8 plus 2, and it was negative 3. Okay, so 8 plus 2 is 10, and that will be my constant, plus 10. So negative 3k plus 10 is my solution. Okay, I have r's and r's, so negative 5 and 8 is the number of r's I have. That will be 3 r's. And then I have 5, which I can't combine because it doesn't have any r's. Next problem, 4z minus a negative, that's plus. 4 plus 3z, 4z plus 3z is 7z. And lastly, this one's a little longer. You are encouraged to write out your work. Anytime holding it in your head is overly challenging, then that's totally fine. So I would write this out because there's 4 different terms. The ones where there were only 2 terms, they were pretty easy, so I did them in my head. You do whatever you need to do. That's up to you. So negative n plus a negative is minus 4. Minus a negative is plus 4n and plus 6. So that first step I took was to get rid of parentheses. That simplifies things. Now I have negative 1n plus 4n. There's no 1 written, but there is an implicit 1. We get lazy kind of in math and don't write a 1 when that's how many there are. If I say n, that means there's 1 of them. There it is. It's the same as writing 1 times n. We just don't do it when there's only 1 of them. Okay, so negative 1n plus 4n's is 3n's. Minus 4 plus 6, that's 6 minus 4 is 2. So we get 3n plus 2, and we are